I just want to show you that there is this tremendous similarity between those two boxes and those two classes that I'm trying to use in the actual code, right? They're like, I cannot draw boxes in source code, but I can say class name. The braces really represent the box itself, the boundaries of the box, right? And inside, I just list fields that I use. Of course, I will be adding operations later on, but I haven't even started to think about any operations. We just say that every pet owner will have those fields, and every pet will have these. Now, since I'm already mentioning string and vector, it's very natural to do something like this. Okay, to include both of these, because those are standard library components. Obviously, they're going to be used in this file, so there's no question about that. That type of thing. So now we can switch over to main, and if I have this main program, what it should do is that before I begin to interact with the user, I would like to simply test my classes by using some silly hard-coded things. For example, I would like to say, for example, pet owner, right? Pet owner, can say pet owner and say owner. I should be able to create an object named owner, okay? And then I should be able to say pet and create an object of type pet, right? So I have pet owner and pet, right? And I can basically, maybe I can test something like this: owner dot add this pet, so that we begin to populate it. Of course, right now my classes won't contain any interesting values. Like by default, every string will be empty string if I construct it with just empty string, and every vector will be empty, will contain no elements, but I can add some operations. So owner, this is the type of the class, so I can say pet owner operations, right? And over here I can say void add, and it will take a pet, an instance of a pet, and I can probably take my pet by constant reference, a reference to a pet, something like that, and I can program this function as I see fit, right? But of course, for the operations to be available within this class, if I can keep my data attributes private inside the class, then the operations that should be usable like this should be declared public, right? So we need to say public to make sure that we have access to these operations, right? So obviously operations are public, whereas the data, we mentioned this last week, we should make a lot of effort to protect the data under protection of the class, and make sure that only functions of this class will be able to access this thing. So let me see if I can actually compile any of this, and if I did make any mistakes or anything. So let's say build it and see what happens. So I've got a whole bunch of errors, which is fine. Says pet undeclared identifier. Okay, so undeclared identifier pet. So unfortunately, pet there is an intent to use a vector of pets, but compiler has no clue what that pet is. So at this point, to keep things relatively simple, what I'm going to do is I'm just going to take this, right, declaration of the pet, and push it up and just declare it before the owner, okay? So this way, if you look at this diagram that I've been trying to use, it seems to be okay to do this because pet, see this arrow? I keep this arrow and it basically says that pet owner has pet, and we already know that it could be multiple pets, not just single pet, but this association suggests that we should not worry about the need to access from pet to the owner, and that's why if we just basically declare pet first, it has no knowledge about the pet owner, but the pet owner then, because this concept is now fully defined right there, right, or at least declared, not fully defined but declared, we can begin using it. So this time, let's, with this update, right, let's build this, and then the arrow says that the linker says, the compiler says everything is fine, but the linker says generating code, and it says that, look, this add function is nowhere to be found. You gave me a promise right here, you gave me a promise that this operation add will exist for the pet owner, but I cannot find it in this application, so hey, cannot really give you an executable program. So that's why we can't really finish this initial stuff without adding a function, member function of the pet owner, right? So that's why we have the pet license.cpp source file. Obviously, anything related to these classes will be placed in that implementation file, whereas the main function will be just a high level of using these objects at runtime. Okay, then, so I will say pet license, move this to the next tab group. I prefer to do most of my programming by looking at things side by side, and what I need to do is that I need to define this operation, and I can just do it in line just as we do in Java, but I will right here I will say essentially copy and paste, right? So just say copy and paste. This is the signature of my function. As always, when you trying to define the function using its prototype, I would suggest first get rid of the semicolon, because if you don't, it's going to just give you some nasty errors that you really don't need. You can experiment with what errors you get, but I usually get rid of it first. And then, of course, we need to say that add is not a standalone function. It belongs to class pet, pet owner, right? So we take this pet owner, okay, and we say that this function is in scope of, class pet owner. And of course, as we're trying to define this function, we need to give it a body, right? So we need to say something like that. I think in my case it's going to be absolutely trivial what it does, because I have this wonderful dynamic array of pets which I predicted a pet owner must need, right? So what I do here, I just simply say pets, right? This is the name of the vector that lives inside the pet owner, right? And we say pets pushback. That was the function I think we've seen. Pushback and ref pet should be a happy, happy parameter to pass to this pushback, right? So what just happened is that if I notice that in main function, first I created the owner. And so the owner box now is somewhere in memory that is a local variable inside this main function. And so I have this variable. Then I created a pet separately, they're all kind of meaningless because no data is populated, strings are empty, and some of these integers could have random numbers. But I need to get some kind of a start on this little application, right? So I'm just going to say this is how I will associate Pat with an owner. So there could be different ways of doing this, but at least this demonstrates association between classes, right? At design time, we just draw the line, which, you know, just this line right here, essentially, I hate that I just touched this button that always causes this thing to crash, so I'll just go back to it. Fortunately, it wasn't... Okay, that's not bad. So it actually recovered lots of it. So what I just wanted to do, just highlight this association, right? And this association in the code appears to be simply saying that, hey, pet owner can have multiple pets, and the realization of this idea is simply creating a vector of pets given to the pet owner, right? So notice that pet has no clue that beyond its scope, someone is actually trying to use it, right? The pet class declaration is self-contained right there, doesn't contain any operations like that, therefore is not very useful, but it's there, right? And so we have both of these, and clearly since vector can have a lot of elements, like billions of them, right? Then we're all set in terms of multiple pets per pet owner.